The goal of this video is to demonstrate how to convert your module from a trailer plug to an Anderson power pole bus connection. Here you can see a converted module with the red Anderson power pole plugs, 2 brass screw terminal posts, and an insulated staple used as strain relief. Here you see an assortment of tools required to convert modules from trailer plugs to Anderson power poles. You'll need electrical tape or heat shrink tubing to cover the soldered joints, some solder, paste, tape, brass screws with a green Robertson, retaining clips with a red Robertson, needle nose pliers, wire strippers, wire cutters, and a soldering gun. Here you can see an Anderson power pole connected to some wire collectively known as a pigtail. The Anderson power pole in this position, you can see that the upper part of the top plug is called a hood because it covers the lower part, which is called a tongue. In this configuration, the wire that goes to the top half of the plug is the wire with the red filament running along its length. When the Anderson power poles are connected, they reverse the polarity of the bus wire. As you can see here, the bottom wire has the red filament running along its length, whereas on the other side, it's the top wire that has the red length. This is important to note as it determines how we will wire the module. A nice feature of the Anderson power poles is that they require very little pressure to pull apart, about 3 to 5 pounds. Practically, this means that when we're pulling modules apart, if the power pole hasn't been disconnected already, it will do so without damaging the module. For this conversion project, I will be converting Cami. Here you can see the 5 steps involved in converting a module. Step 1, it will be to orient the module with the top of the module facing up. This can sometimes be confusing when modules are packed together. Step 2 is to place tape on the left side of each module's end. This will help in orientating which wire goes to which bus. Step 3, we'll need to remove the trailer plugs by unsoldering the connection. Step 4, we'll need to solder the Anderson power poles onto the ends of the bus wires. And step 5 will be to attach strain relief and secure the end of the power pole. Step 1 is to orient the module. In this case, that the top of the module is facing up. As we move to the end of the module, you'll notice that step 2 is to place some tape on the left side of the end of the module. As we move to the other end, it may seem confusing that it's on the opposite end of the other end. However, this is because of the reversing nature of the power poles, as I demonstrated earlier. Step 3 is to remove the existing trailer plug. In this case, I'll have to remove the strain relief, remove the electrical tape, and then unsolder the connection. Now with the strain relief removed, I'll remove the black electrical tape exposing the soldered connection. Here you can see the exposed soldered connection. The next step will be to unsolder them. This will be done by heating up the soldering iron, applying some flux to the solder joints, tinning the soldering iron with a little bit of solder, and then applying the soldering iron to the joint until the existing solder melts, at which time you can pull the 2 wires apart. This step is much easier with a helper. So here I'm applying some solder paste to the joints to help the heat flow. Okay. The next step is to tin the soldering iron by applying a small amount of solder to the tip of the hot iron. Now we apply the soldering iron to the joint and heat until all the solder is melted and we can separate the wires. You may need to apply additional solder to the joint. And then we repeat with the second wire. The next step is to prepare the bare end of the Anderson power pole pigtail. In this case, in order to get it ready, we will need to strip the ends and then tin them. We'll use the wire strippers and the soldering iron. You'll want to strip about 3/4 of an inch from each end and twist the wires. To tin the ends, you'll want to apply some solder flux to the ends of the wire, put some solder on the tip of the iron, and apply it to the bare wire until it melts and flows out smoothly. So here you can see the bus wire ends and the power pole pigtail ends. Both sets of wires have been tinned or ready for joining. You have two options. You can install a brass screw and use it as a terminal post, or you can loop the ends of the wires, as I'm about to do, and connect them together, then solder. For step 4, attach the Anderson power poles. We must now look at where we place the tape. As you remember, the Anderson power pole pigtails have 2 wires, and one of those 2 wires has a red stripe on it, as shown here. That red stripe must get connected to the power bus wire closest to the tape, in this case the black wire. Here I'm attaching the bus wire with the red to the black wire and connect it with the 2 loops. Now I'll take the needle nose pliers and squeeze the 2 wires together tight. With the 2 wires connected and squeezed tightly, I'll solder the joint in the same way as before by applying some flux and then applying a tinned soldering iron to the joint. And now for soldering the connection. With the wire ends now soldered, I'll wrap them with electrical tape and secure the wires back in place. And here's the final connection with the straining relief installed. I've used a washer covered with electrical tape, but the preferred method is an insulated staple. Here's an example of an insulated staple. The last step is to install one of these clips to hold the end of the pigtail in place for storage. Here you can see the completed project, the pigtail ending in the clip. Now with both ends wired with Anderson power poles, you'll want to test the module to make sure you have continuity through both bus wires and there are no shorts.